4.2 logarithmic functions. So for every exponential function, f of x equals a to the x, they're 1 to 1. So therefore we know it has an inverse, and that inverse function is a logarithmic function with base a. So it's called log base a. Logarithmic functions with base a take the form log base a x equals y, and we can switch that over to an exponent for calculation purposes for a to the y equals x. So for example, if we are given logs and want to change them to exponents, 2 is in the a spot, so a y log base a x equals y, so a y equals x. 2 to the third is 8. In the a spot we got 4. In the y spot there's 4, so 4 to the fourth is 256. Going backwards, we got log. Instead of a, we're putting 2. X is 1/8 equals -3. Oh, we should have a 1 right there. For 5 to the third is 125, so as a log base 5, 125 equals 3. So for graphing logarithmic functions, we're going to take the exponential function y equals a to the x and reflect it over the line y equals x. So this is the line y equals x. We have our curve. It has the exponential function has a horizontal asymptote of the x-axis, so we are going to have a vertical asymptote of the y-axis. So, we're going to start by being very close to the y-axis, but never touching it. And then it's going to pass through the point 1, 0, typically to 1, depending on the curve, and going up. The blue passes through 0, 0, 1, so its inverse passes through 1, 0. So, if we need to graph by hand, suppose we have f of x equals log base 2 of x. So let's set it equal to y and put it into an exponent. So 2 to the y equals x. So we're going to make a table of values. Y is in the exponent spot, so we're going to write x's using 2 to a power for easy calculations. So let's start at 1. That means that 2 to the y equals 1. That has to be 0. 2 to the 0th is 1. If we have 2 to the first, that's going to make y be 1. 2 squared, that would make y 2. 2 to the third will make y 3, and we have to do negatives as well. So let's go 2 to the negative first, that will make y negative 1. 2 to the negative second, that will make y negative 2. And 2 to the negative third, that will make y negative 3. So when going to graph these, some of the points are easier than others. We have 1, 0. We have 2, 1. Then you got 2 squared, 2. So 2 squared is 4. Up 2. 2 to the third, 3. So 2 to the third is 8. And up 3. On the other side, 2 to the 1/2. 2 to the negative 1 is 1/2. So 1/2, negative 1. 2 to the negative 2 is 1/4. Negative 2. 2 to the negative 3 is 1/8. Negative 3. So we just graphed log base 2 of x. Now we're going to use our transformations that we know from chapter 2 on the next two. G of x equals negative log base 2 x. So that just means we're going to reflect it over the x-axis. So we're starting down here and going up, so we're going to start up and go down. We will have a common point of intersection at 1, 0, and then it will start going the other way. So we're just reflecting over. So this is negative log base 2 x. Now the negatives in with the x. Remember from chapter 2 that this is also a reflection, but over the y-axis. So we are taking this curve and reflecting it. And it goes the other way. So this is the graph of log base 2 of negative x. Going the other way. So once again, we're going to be doing some more graphing. Our base graph is going to be log 2 of x. So put that on there. But now we're adding 3 to it. Adding 3 is a vertical shift up. So we are going to shift up 3 spots. So we're taking all of these and moving them up 3. Now we're adding 5 to the x in the parentheses, so that's going to be a shift left or right. And it's adding, so we do the opposite and go left. So we are going left 5 from the original base, log base 2 of x. So we're here, we move 1, 2, 3, 4, 5. And that is how you can use the transformations to graph logs by hand.